Hello everyone, welcome to Career Point Electrical. Today we'll discuss why DC is not given to a transformer. Let us discuss why DC is not given to the transformer. As you know, in a transformer always AC is provided. So if we provide DC, then what will happen to the transformer? The common answer is, if DC is provided to the transformer, then the winding is burnt out. Winding is burn out. So why, if DC is provided to the transformer, why winding is burned out? If AC is provided, there is nothing, winding is safe. But if DC is provided, the winding is burned out. So for that, I will draw a transformer. So this is my transformer, and this is my primary side, and this is your secondary side. Secondary side. So if I provided AC, then just I will discuss what is the principle of transformer, working principle. Principle of transformer. As you know, transformer is working in the Faraday law of electromagnetic induction. So what is the Faraday law of electromagnetic induction? If there is a relative space or time variation between the magnetic field and conductor, then a EMF will be induced. So for here transformer, the relative time variation. So there is coming the famous equation, E is equal to minus N d phi by dt. So this is your Faraday law of electromagnetic induction. So now here E is produced, let it be E1, so E1 is produced. So then why E1 is produced? Because my voltage V1 is alter AC. So what is my nature of current? Current is also AC, that is rate of change. So if the current is AC, then my flux produced phi is AC. Okay, so the flux is continuously changes and it will link to the secondary winding, and there will be a, due to this flux there will be a voltage induced in the secondary winding. So if DC is provided, then my current is nature is DC, that is your direct current. This is not changes, it is constant. So the rate of change is 0, that is d phi by dt is 0, because I is constant, that is E is equal to minus L di by dt. So if di by dt is 0, why di by dt is 0? Because the I is constant, it is not the changes, that is it is not alternate. So di by dt, the rate of change of current is 0, so voltage is 0, that is E is 0. If E is 0, then my mutual inductance is 0. So again my self inductance is 0. So for E 0 means voltage 0 means the circuit or the winding is short circuited. So as you know, the winding is short circuited, that means heavy amount of current is flowing, there is no voltage, so the winding is burnt out. This is one point. Another point is, for DC, you know, frequency is 0, that is no frequency. In DC there is no frequency. If frequency is 0, then what is my Z value? Z value is 0. So my impedance is 0, but there is a presence of resistance, it is very low, the resistance is low. So if the resistance is low and Z is 0, then at starting there will be heavy current flow due to frequency is 0. That is, if I will take a 240 by 120 volt 50 hertz transformer, then what is my current? So what is my primary current? As you know, primary current is 240, and my R1 is equal to, that is your primary side resistance is 0.1, and R2 is equal to 0.1, that is 240 by 0.1, that is equal to 600 ampere. So at starting the current is high, current is flowing. So if high current is flowing, then it will burn the primary winding. So this is another point. So the general equation is I is equal to V minus E by Z. Okay, this is my generalized equation. So as you know, what is E? E is the EMF induced due to the Faraday law of electromagnetic induction. So if E is 0 and Z is not present, Z is very low, so the heavy current will flow. Now, so again question is, if transformer will not given AC, sorry, will not given DC, then why in DC motor or DC generator will provide DC? Because so in a self-excited, sorry, in a separately excited DC motor or synchronous motor, we provide DC. Then if we provide DC to the separately excited DC motor or synchronous motor, the winding will not burn out. Why? Now we give very low power DC. So if low power DC is provided, then we get low value of current, low current. So it will, so the current is withstand by the resistance or winding resistance. So for separately excited DC motor and synchronous motor, you provided very low power DC. So if we provided low power DC, current is low, so this current will be withstand by the winding resistance, so it will not burnt out. So again, point 2 is, if we provided low value DC, so if low power DC is given to the transformer, so if I provided low power DC, then winding will not burnt out, winding will not burn out. So it is perfectly correct. If you can provide a low value of DC to the transformer, but there is no transformer action is 0. So if we provide a low value of DC, then it is okay. Again, we'll discuss why in DC motor or AC motor, stator is provided, but in transformer no stator. So for this question, you just see that in DC motor or AC motor will provide stator. Why we provide stator? To start the machine or to start the motor, will provide the stator, but in transformer will not provide the stator. Why? Because in DC motor or AC motor, stator is provided because you know what is my starting current? IST is equal to V minus E by R or Z. This is no equation. So in DC, so you just know the machine is, the winding is safe due to this E, that is your, for transformer it is your induced EMF, but for motor, DC motor, it is your back EMF. So but in starting there is no back EMF, it is 0, back EMF is 0, so heavy current will flow. So due to reduce the heavy current and save the winding, we will provide a starter to the DC motor and AC motor, but in the transformer we will not provide the starter because the transformer has starting current which is depends on the time constant, and in transformer we will get high time constant. So due to this, starter is not provided to the transformer, but in DC motor and DC or AC motor we will provide starter due to the low time constant and back EMF is 0. So to withstand the winding, with a heavy current will provide starter. So in this video we will discuss two questions, that is why DC is not provided to the transformer and why starter is provided to the AC motor or DC motor, but in transformer we will not provide the starter. So more video, you will go our channel and subscribe our channel and hit the bell icon. Thank you.